Hi everyone, my name is Farmer Erin and today we're going to be talking about soil. So we're going to be talking about soil, not dirt. Soil is an amazing thing. It is a living thing. It allows us to grow food and provides home for animals all over the world. And even across the globe, there are many different kinds of soils that have different water capacities and hold different amounts of air. There's so many things that we can learn about soil, but today we're going to be talking about the three different components of soil: sand, silt, and clay. And I'm going to show you an experiment on how you can see how much of those three components, sand, silt, and clay, you have in the soil outside of your house. But first of all, I have two different discussion questions for you guys. So, what are the 5 factors that influence soil formation, and why might some soils be better than others to grow food? So for the first question on what are the 5 factors that influence soil formation, the first one is living organism. The second one is topography, which is basically a fancy way of talking about the slope of the land. So that's looking at a flat grassy plain versus a very steep mountain. So if you have a mountain, you have the pull of gravity coming down, and if it rains at the top, that rain is gonna, when it runs down the side of the mountain, is gonna be able to pull more soil with it as it goes down because of the incline. If it were a flat plain, the rain will fall, but it may not have that same pull, same effect as it would on the side of a mountain. So that's what topography is talking about. The third one is time. Obviously, soil takes a long time to form. Really, to form like an inch of soil, it can take over like 500 years, even thousands of years, depending on what the parent material is. That's number 4. So all of our soils, they come from rocks, and depending on what kind of rock, so obviously in a place like Hawaii, where they have many volcanic eruptions, that soil base, that parent material, is a lot different than the soils we have here in Michigan. So kind of the parent material, some stuff will be easier to break down than others, and it will provide different nutrients. When we're talking about breaking down, our 5th factor is the climate. So this is talking about the weather and things like that. So, for example, with Hawaii again, it's fairly warm there all year, especially compared to Michigan, but they also receive a lot more rain than we do here in Michigan. So they may not have the freeze and thaw like we do here, but they have a lot of rain. So the rain is a good example, and our different seasons here in Michigan, summer and winter, those are both good examples of how climate over a long period of time, 500 plus years, can wear down that parent material to create soil. So those are the 5 things that go into soil formation: living organisms, topography, time, parent material, and climate. For the next question, why might some soils be better than others to grow food? It's because plants have all different needs. So here in this pot, I have some succulents. Their needs are different than what these vegetable seeds are going to need to grow. So when we're looking at soil, it's important to pay attention to the nutrients, any living organisms like worms that, burrow down in there and create tunnels for water to infiltrate into the soil. So you need water in the soil. And that is going to be kind of what we're talking about today. So we're going to look at how sand, silt, and clay can affect a soil's ability to hold water, let water get into the soil, and things like that, because that plays a huge role in if the soil is good to grow plants in. For example, if there's a soil where water can't get in, then it will be hard for water to get to the roots of the plants, and plants need water to grow. If the soil lets all the water run through it before the roots have a chance to take up any of the water, that also could be hard for plants to survive and thrive in that. So we're going to be doing an experiment to test our soil outside to kind of see the different combinations of sand, silt, and clay, and how each of those play a role in water holding capacity and water getting into the soil. So I will be talking about the difference between sand, silt, and clay next. So we're going to be talking about the three components of soil today: sand, silt, and clay. As we go through these definitions, I'm going to need you guys to kind of use your imagination just to picture this so you can learn more about the size of the individual particles of these different components. So to start us off, Anna-Lane, can you define sand for us?
Thanks, Erin. Sand is a loose, granular material that comes from rocks breaking down. So it's smaller than gravel, but bigger than the other materials we're going to see today.
Thank you, Anna-Lane. So sand is the biggest one of the three and the heaviest. That's going to be important later. If we were going to compare sand to something that we had in our lives, just for size comparison, I want you to imagine a single piece of sand being the same size as a beach ball. Okay, so one piece of sand is the size of a big beach ball. For our next one, we're going to be talking about silt. Anna-Lane, can you define silt?
Thanks, Erin. Silt is loose sediment that also comes from rocks breaking down, but the particles are much smaller than sand.
Perfect. Thank you, Anna-Lane. So if sand, a single piece of sand, is a beach ball, one piece of silt is about the size of a frisbee. So just imagine that. Sand is a beach ball, silt is a frisbee. So smaller and not as heavy. It's a little lighter than sand. So we have a beach ball and a frisbee. The last one we're going to be talking about is clay. Anna-Lane, can you define clay for us?
Thanks, Erin. Clay is an earthy material that is plasticky when wet, but hard when it dries. And it's made of very fine particles and minerals, which makes it hard for water to get through.
Thank you. Okay, so we got the last one. So we have sand being a beach ball, silt being a frisbee, and a single piece of clay, if we have a beach ball and a frisbee, is the size of a dime. So very, very tiny and very lightweight. So we have our heaviest sand, our middle weight is silt, and our lightest is clay. And that's going to be really important when we talk about our experiment. So just kind of something a little more about sand and clay on our two ends, our biggest and our littlest, is water runs through sand really fast. Because if you have a bunch of beach balls, if you filled a room with a bunch of beach balls and poured water in the top, there would be these huge holes for water to run through to the bottom. So water gets into the sand really easily and will run all the way to the bottom really fast. On the other end, with clay, if you filled a whole room with a bunch of dimes all the way to the top, and you poured water on that, it would be really hard for water to try to get in between all of those spaces. It may not even be able to in some cases, in some areas of the dimes. And once it did, it would take a very long time for water to finally reach the bottom. So it's good to have a mix of all three, sand, silt, and clay, because if you have just sand, all your water is going to run right through, which wouldn't be good for plants. And if you have all clay, then water may not even be able to get into the soil, and that's not good for plants either. So in a moment, I'm going to be demonstrating how I set up this experiment right here using some old bottles that I had. You can do this small one in a regular bottle, or I had this large bottle. So I'll show you how I set up this experiment to test how much sand, silt, and clay I have in the soil in my yard. So here it is. All right, so I'm gonna show you the basic setup of this experiment. The good thing is that it really doesn't take a lot of materials at all. The main part is having a good plastic bottle to use. You can use a small water bottle if you would like. I just have this big one so it's easier for you guys to see. The important thing to remember when you're picking out a bottle is to find one that has a cap, no holes in it, and it will stand up on its own. That's going to be very important because we are going to be shaking up this bottle when we have our soil and water inside, and we don't want us to get covered in soil and water during that process, and we want it to be able to sit up on its own so everything can settle to the bottom. The other things that we're going to be needing, like I just said, are soil, which I'm going to go outside and dig some of that up, and water. I'm going to fill that up here at the tap. And another good thing to have is a cloth, so when you are shaking it up, you can hold it right on top like this. So if for some reason the cap does come off, you won't get covered in what's inside. So the good thing about this is that this whole experiment can be set up outside. You can use a garden hose to fill up your water. You can dig a hole outside. It's best to do it out there so then it keeps the inside of your house nice and clean. I'm going to fill up our jug about halfway with water as our first step. So I'm gonna do that right now. So I have this jug filled up halfway with water. The next step that we're gonna do is we're gonna go outside and we're gonna fill it up with soil so it probably goes about up to here. We want some airspace still in the bottle so when we shake it, it's easier for things to move around. So let's go outside. So here is the small patch of soil that I have selected. I have already used the shovel to fluff it up just like this. Any big pieces like this where you don't know what they are, you're going to want to take this and just put it to the side because that is not needed for this experiment. So I'm going to bring down the bottle and I'll start filling that up. So I have the bottle. I'm going to start doing little tiny scoops. It may not, it's going to be kind of hard because the soil is a little wet. So now I have my bottle filled up with soil. There's this much water or air still in the top, which is really important because we're gonna shake it in just a moment and that helps the water and soil that is inside move a little easier. So I have my red, I'm gonna hold that on top and I'm gonna shake for probably 2 to 3 minutes. And we'll, because you want to break apart all of those soil pieces that are like clumped together. The soil that I was digging in today, it had just rained, so things were kind of sticking together. And when you shake it up, you want all of those pieces to be broken apart, because then what we're gonna see is after we've broken them apart, we're gonna let this sit overnight and we're gonna see how things settle out. And obviously the heaviest pieces will settle first, so all of the sands, and then the silts, and then the clays are the lightest, so those are gonna be on the top. So the important thing is we wanna break up all of those sand, silt, and clay pieces to see how they settle out in this bottle. So I'm gonna give it a go. So this is pretty good for right now. I'm gonna shake it up a little more, but we're gonna head back inside and we'll get right back into it. So both of these bottles have been sitting for 24 hours. This little one is from my friend's garden, from a hole I dug in my friend's garden, and this big one is from my garden. So when you're looking at the different layers, because remember, sand is the heaviest, so when it's all shooken up in the water, it's gonna settle to the bottom first because it weighs the most. And then silt will be our middle layer, and then clay will be on top because it's so lightweight, it takes a very long time to settle. And so when you're looking at these samples, you may have to shine your phone light or a flashlight on them to really see the different layers, but then you can kind of estimate about how much of sand, silt, and clay you have in your sample. So for my friend's house, I had about 30% sand at the bottom, about 65% silt, and just a little bit of clay at the top, only like 5%, so not a lot of clay. At my house, I found about 30% sand, so the same as my friend's. Silt was about 20%, and then I had 50% clay. So that was a lot of clay found at my house, just like half of it was clay. And so I'm going to be showing you in a moment on some charts how scientists will use these to figure out what kind of soil you have based on those percentages. So here, check this out.
So here's this crazy looking graph that scientists use to tell what kind of soil it is based on those three things: sand, silt, and clay. So remember how I was just sharing those percentages from my friend's garden and my garden? Well, I'm going to show you on this graph how to figure out what kind of soil it is based on those percentages. So for my friend, he had 30% clay in his sample. So down at the bottom on sand, we find that 30. We'll circle that. And what I want to do is highlight that entire line going up from 30 for sand. And we'll just leave that there. And then for silt, we're gonna go over, and it was 65%. So we go over to the right side where it shows silt, and right in between 60 and 70, that's 65. So we're gonna draw a line down. We're gonna highlight that whole line. So we finished that. And the last thing we have is clay at 5%. So over on the left side, that's where it shows clay. And we know that 5 is half of 10. So right there on that first line, and we're gonna highlight that whole line across. So where all of those intersect or connect, that's the kind of soil that we have. So for ours, it ends up being a silt loam. So my friend has a silt loam soil in his garden. So he can do more research based on that to see what he might need to add to make his soil better for his plants. Or it could be perfect just the way that it is. For my garden, we'll do this activity again. So I also had 30% sand. So down at the bottom, we have the 30. And we're gonna highlight that whole line up for 30. So we got that done. For silt, I only had 20%. So that's on the right side. Almost all the way at the top, we see that 20 for 20% silt, and we're gonna highlight that whole line all the way down. And then for my clay, I had 50% clay. So over on the left side, where it shows 50, I'm gonna highlight that whole line across. So my soil ends up being a clay type soil, which isn't the best for growing plants because not a lot of water can get into it. But we'll talk more about what we can do to change that to make it better for plants.
Okay, so now to wrap us up, I have 2 different questions for us. The first one is, what are the 3 particles of soil? I've been saying this one a lot, so hopefully you remember it. That's right, sand, silt, and clay. We remember that sand is the biggest, it's our beach ball particle. Clay is the smallest, it's the little dime. It's so small that you would need a microscope to see a single piece of clay, so very, very tiny. And my second one is, what particle makes it hard for water to drain? And what can we do to change that? I hope you guessed clay. Yeah, clay is really hard, makes it really hard for water to drain through. Because remember, if we imagine that room full of dimes, all those dimes stacked on top of each other, it would be really hard for water to work its way down. But as you remember us talking about with sand, the big beach balls, if we mix some sand into that clay, it would make it easier for water to get in. On the other side of things, if we had a bunch of sand and we wanted it to hold more water to kind of keep water in there, so if we had plants, the roots would have time to take up that water. We could add in some compost, some organic materials. That's kind of the same to help hold onto the water as clay sort of does. So I hope you enjoyed our lesson today. I hope you have a chance to go make your own soil experiment, soil composition experiment. Remember to do it outside, and have a good day. Bye.